Hi, everybody. My name is Karen Moore. I'm the director for the Center for Nanophase Materials Sciences at Oak Ridge National Laboratory. I'm going to be talking about not only the Center for Nanophase Materials Sciences, but all of the nanoscale science research centers, or the NSRCs, all of which are DOE Office of Science User Facilitators. So I'm going to be talking about the entire network. So the Nanoscale Science Research Centers were initiated in the early 2000s by the Basic Energy Sciences Office in the Office of Science. The BES established 5 NSRCs in support of the NNI, and this was done primarily to establish nanoscience leadership in the United States. So we have 5 NSRCs, as you can see here. They're listed around the map of the US. The 5 NSRCs are located at 6 national laboratories, and this is because the Center for Integrated Nanotechnologies down here is actually located at 2 facilities, one at Sandia and one at Los Alamos. You can see the molecular foundry is on the campus of the Lawrence Berkeley National Laboratory. The Center for Nanoscale Materials is at Argonne National Laboratory. The Center for Functional Nanomaterials is at Brookhaven, and the Center for Nanophase Materials Sciences is at Oak Ridge National Laboratory. So they were initiated in the 2000s. In the mid-2000s, they started operating. All of them started operating within a few years of each other. The total initial capital investment, and as well as more recent investments, is about $500 million. We are currently working on a major recapitalization project at the NSRCs that will involve putting state-of-the-art equipment at the different nanoscale science centers. This is a major project with the DOE, and we're hoping to invest anywhere from $60 to $100 million in the recapitalization. Because over the last 10 years, we haven't really, other than what we normally would use to recapitalize our facilities, this is a major influx of money for us. So it really puts us at the leading edge of being able to do a lot of the nanoscience research. The budget for all 5 nanoscience centers is about $135 million every year. So the NSRCs are unique amongst the DOE user facilities because we have this dual role or dual mission, if you will. We have, of course, a state-of-the-art user facility, and it's very collaborative in nature. And this is because it is supported by expert staff. We don't just have people come in and use our capabilities. They're very advanced in most cases. They're very unique. And so the advantage of coming to an NSRC is that we provide our users with staff expertise to go along with using the cutting edge instrumentation that we have at our facilities. But our other major mission is to conduct in-house nanoscience research. And this internal research is carried out by our staff members, and its basic role is really to support the facility, to advance new capabilities, to advance science so that we can support our users with advanced knowledge in these fields. So we've been in operation now for about 10 years, maybe a little bit more. And we have really some of the top scientists in the world working in the NSRCs, and they are there, again, primarily with this dual mission of working with users, providing that expertise, and conducting in-house science that then integrates with our user facility mission. So we have 5 NSRCs. The NSRCs operate as a network. We are not in competition with each other. And in fact, each of us has an identity, if you will, and a strategic focus that defines our strengths. So you see the 5 NSRCs listed here. Each NSRC, again, has an in-house science program, and each one is focused on different things. So for instance, we'll talk about the CFN. One of their major research focus areas is in operando characterization of materials. And so they have specialized instrumentation to be able to image and characterize materials under relevant operating conditions. The CNMS has some of the most advanced electron and scanning probe microscopies coupled with spectrometry, so that we can do advanced not only imaging but spectroscopy to understand materials behavior. So there's a NSRC for just about every need. In general, each of the NSRCs is also equipped with a fairly standard set of nanoscience tools. So each one has a clean room. Each one has basic instrumentation to support a lot of the work that goes on in the nanoscience centers. And as well as each of us has our own unique focus on signature instrumentation, which makes us different from the other nanoscience centers. So the capabilities at the NSRCs are typically associated with, again, the nanoscience expertise. Some NSRCs will have stronger programs in, for instance, imaging, and I can certainly look to 4 of the NSRCs, the Molecular Foundry, the CFN, the CNM, and the CNMS, all have advanced imaging capabilities, again, with a unique focus as to what their expertise is in. All of the nanoscience centers have theory and simulation, a very strong program in theory and simulation, and in many instances are coupled with high-performance computing capabilities. So if that's an area that you're interested in, then of course the nanoscience centers support that type of research. All of the nanoscience centers do material synthesis. Each one, again, focuses on a specific area, and I can point to the CFN in their expertise in catalysis. CNMS has an expertise in polymer synthesis and 2D materials, and that doesn't mean that that excludes what the other people do. It's just what we typically focus on. And a lot of the nanoscience centers have different capabilities for developing new materials. So it depends on really what you're interested in as to which NSRC would have the strength in that particular area. Most of the nanoscience centers, as I said, have a clean room and have equipment for nanofabrication, a wide range of equipment for doing nanofab. So these are typically the bins of how we describe what our NSRC capabilities are and where our strengths are. So many of the NSRCs are also co-located with larger user facilities. You think of X-ray and neutron scattering facilities. So those are listed here. You can see LBNL has the advanced light source. Argonne has the advanced photon source. Brookhaven has the NSLS2. Oak Ridge National Laboratory is the neutron scattering facility, has HIFER and the spallation neutron source. These are all capabilities that are accessible together. So one of the reasons that the NSRCs were put at some of these facilities was so that they could be co-located with these larger user facilities, and each one acts as a gateway to the other. So for instance, at the CNMS, you can write a proposal to the SNS or to HIFER and be able to access CNMS facilities through that user proposal. You don't necessarily always have to write 2 user proposals to access that. Now that I've described the scientific impact of the NSRCs over the past 10 years has been quite significant. You can see from these statistics, we have supported 30,000 or more users and the science has resulted in over 14,000 peer-reviewed publications. So again, the impact in the fundamental research that's done at the NSRCs has been significant. We support users as diverse as Nobel laureates and high school science educators. A lot of the national labs have programs that bring in teachers, and they take advantage of not only accessing the equipment, but learning about many of these capabilities that they don't have access to in their normal lives. We are bridging, building bridges with industry. This has been a challenge for us because a lot of the work that we do is fundamental in nature, and selected industries are interested in that, but not all. So industry is a bit of a challenge, and I'll explain that a little more in the next slide. But there's a lot of advantages to the nanoscience centers, not only in supporting academia and other national laboratory or government laboratories, both domestically and internationally, but it teaches early career graduate students, early career staff in industry, at academia, some of the scientific techniques and methods, new methods. We're at the cutting edge of bringing in capabilities to answer specific nanoscience questions. And these are capabilities that sometimes and many times you can't get at any other facility. So it's a great opportunity for people to come in and learn about these new methods and the advantages that they might have for their scientific research. It also teaches safe lab practices. The government labs are have very tight ES&H controls, and it really teaches safe lab practices, which are especially important for graduate students. And it enforces a culture of collaborative science. Here again, we don't allow users at the NSRCs to come in and just work on their own. They're there not only to have access to these cutting edge instruments, but to also pick the brains of leading scientists and understand how to take these advanced methods and apply them to their challenges or their scientific questions. So this is, again, one of the biggest advantages of the NSRCs is the fact that they have staff who work with users one-on-one while they're visiting and help them to understand the work that they're doing. Finally, accessing the capabilities at the NSRCs. The one thing that we'd like to advertise, of course, is that access is free. If you're conducting non-proprietary research that can be published in the open literature, and this is absolutely very important, it will be free of charge. You can come in and use our capabilities, work with our staff. You get these access to world-leading capabilities. And again, the staff expertise. This is very, very important for many institutions worldwide. If the research, the nature of the research is proprietary, and this is the issue with industry many times, there is a fee that can be charged for you to access some of the advanced capabilities should you need them. And those have to be worked out separately. But 95% of our users are coming in to conduct non-proprietary fundamental research that they then publish, which is why our publication rate is so high, because not only do we publish our internal research, but our users publish the research that was conducted at the NSRCs. This is access to the NSRCs are granted via proposal peer review process. It's an external committee that assesses each proposal for scientific merit. We do want to provide capabilities for advanced scientific discovery. We're not really here as a service center to provide access to sort of normal instrumentation. We like to be on the cutting edge of science. And again, it's important for us to show impact of the NSRCs by assessing the proposals based on the scientific merit and the challenges that they pose. Proposal submission cycles really depend on the NSRC that you're looking at. They typically can be aligned with the other facilities at the national lab, The calls are typically 2 or 3 times a year. There's a lot of opportunities to write new proposals. Each of the facilities also offers rapid access proposals where you can, if you have a relatively short-term project that you need to do, you can come in for a couple days and get that done. But we typically like to have people submit full-scale proposals. These are short. I say full-scale proposals. They're short. They're typically two to 3 pages of answering questions and defining the work that you want to do and the challenges that you have in doing it. So again, that goes back to scientific merit. When accepted, most of the NSRC proposals are active for 1 year. Some of the NSRCs are 2 years, but most of them are for 1 year with the chance to extend for an additional year. So there's most of the proposals that are submitted and accepted will run for 2 years. All the NSRCs in the past have required on-site participation by the users. This is pretty much non-negotiable. There are opportunities such as in theory and simulation for doing remote access, but on-site participation is how we define our users, because again, it is highly interactive, it is highly collaborative. That doesn't mean that people can't come in and if they're experts in using a capability and use the facilities, but in most cases we are working together with our users. Of course, this has been redefined because of COVID. Over the last 9 months, the NSRCs have been operating primarily in remote operation mode, whether this means using augmented reality glasses or having remote sessions via Zoom while we're doing the experiments. We still want our users to participate in the experiments and to work with us in a collaborative way. So DOE has been redefining how we operate with our users. So this is very good in these times that are quite difficult. So this is my last slide, but I wanted to point out that you can go to any of the websites that are listed here or contact any of the NSRC directors that are also listed here for information that might be specific to the types of experiments or the types of studies that you want to do to see which NSRC would be the appropriate one to go to for your problem and what the different capabilities are. If you just go to the websites, you can actually see all the great capabilities that are at each of the nanoscience centers, and you can make those decisions about where to go, where to submit a proposal, and who the experts are in the field. That the staff are all listed on the websites too. And with that, I will thank you for paying attention, and please contact the NSRCs if you are interested in doing some nanoscience research. Thank you very much.